Okay, welcome back to Algebra 1 Honors. We are going to continue on in Chapter 9. We're going to take a little digression from our cows and people in the barn, and we'll come back to that in 9-5. Okay? We've looked already at solving systems of equations using graphing. Okay? Probably a method you won't use much except maybe on the test, right? And then record up it. And then we've done substitution, that's nicknames. Okay, we did that one in 9-2. Now, we're going to skip ahead to lesson 9-4, and this is the third method, the first part, I should say, of the third method, which I call elimination, okay, because that's what it reminds me of. We're going to eliminate one of the variables very quickly, all right? Your book calls it the addition-subtraction method, and then 9-5 is actually a little bit added on to that, the addition-subtraction method with multiplication. Okay? So that's why we're breaking this into two parts. So when you see the elimination method, in your head just translate, that's what my book calls the addition-subtraction method. Okay? So that's what we're going to use here. Now, our goal is still the same for our system of equations, and that is to find an xy pair, right, a value for x and a value for y that makes both of our equations true. The same x and y has to go into both equations to make them true sort of at the same time, if you will. That's why it's called a system of equations or simultaneous equations. Okay? Now, the way we're going to do that, when you look at these two equations here, don't they look awful? Oh boy, when most people see fractions, Mr. Justin sitting back there, doesn't this scare you?
Yes.
Look at all these, look at these giant fractions here. Ew, how icky.
Yeah,
Most people are already in panic mode here. Okay? But watch how easy it is. Now, your eyes should also be telling you something else here. Okay? And I always tell you, when you're doing math, your eyes are a powerful assistant. Your eyes should be saying, oh, hello, brain. That fraction looks just like this one, except there's a plus here and a minus here, all right? So your visual processors, boy, to get a robot to figure out that this looks like this is a real challenging task. But your little brain does it right off the bat. So we're going to make use of that. This coefficient, this fraction, and this coefficient here are exactly the same, except their signs are different. Now, if you think about how we solve equations, right? An equation's like a teeter-totter. Okay? So, here's my teeter-totter. And in my top equation, those two things balance. In my bottom equation, those two things balance. Okay? So if I add them together, that'd be like having two really big people up here, two football players, and they balance, and two little acrobats down here, and they balance. If I put a football player and an acrobat and a football player and an acrobat together on the same sides, if they balanced originally, they're going to still balance. Right? So I can add, it's kind of weird, but I'm going to add my two equations together. Okay? Now, when I do that, oh, a wonderful thing happens. When I add here, right, so let me put my line. Here's my addition line. Yeah. I'm going to add everything together. 4x and 2x, ooh, I get 6x. But when I add here, this is why it's called the elimination method. This and this are opposite. So I have this many y and the opposite of that many y. That means when I add them together, I get 0y. So my y term is eliminated. It disappears. Okay, so I'm not even going to write 0y down here. And then I add over here, and let's see, I get a 0, carry my 1, a 0, carry my 1, a 0, carry my 1, and I get 60,000. Oh, now this equation's easy to solve, right? I got to divide both sides by 6. Okay, and I get x is equal to 10,000. So I already have half my problem solved, 10,000. Now I have to go back and choose one of my other equations, plug in my 10,000 for x, and get a solution for y. Okay? So I'm going to do that. I'm going to erase the top here. And we're going to take our 10,000 that we got for x there, and we're going to plug it in and solve for y. So if I put 10,000 in here, okay, I'm going to get 2 times 10,000, that's 20,000, right, minus icky fraction equals 7655. Okay, now then, let's see. I'm going to subtract 7655 from both sides. Okay, and that's going to give me what over here? 4, 5. It's going to give me that over here. Okay, and okay, that's what I have so far. Now, then I'm going to move this just because it's negative and I don't like negatives. I'm going to move this to the other side by adding this to both sides. So that means I'm going to have to come up here. I'm just adding this to both sides. Okay? And then to get rid of that fraction in front of the y, I multiply by the reciprocal. Remember? Multiply both sides by the reciprocal of this. There's its reciprocal. And over here, I'm going to multiply by the same thing. Okay? Now, on that side, when I multiply by the reciprocal, remember, because it's all multiply there, that goes into that once, and these cancel, and I get just my y there. Ooh, almost there. And over here, let's make this guy a fraction by putting him over 1, and then I can cancel. That goes into that once each, and I'm left with just 6, 7, 8, 9 is what y is. Okay? Now, to be sure, I really need to go back and to both of my original equations, put this value in for y and my 10,000 that I had in for x, and make sure that it works in both equations. Because if it doesn't work in both of them, then I've made a mistake somewhere. Okay? But this is the idea of elimination. Now, let me show you one that's just a little bit simpler. Okay? Because this one was to give you an appreciation for why you might want to do elimination. Because sometimes you can very obviously make a problem simpler using this method. Let's do one more like what your book will give you. It'll be something like something like this. Okay? Now, the reason I want to use elimination here is because my objective is to get rid of one of my variables. And if I look at my y's here, oh, I've got a positive 1y and a minus 1y. And if I add them together, that's going to give me 0 y's, and the y goes away. So I'm going to add everything together. 3x and 4x, I get 7x. The y's are eliminated. And over here, 6, positive 16, negative 2, I get positive 14. Divide both sides by 7. Then I get x equals 2. Go back up, choose one of my equations, doesn't matter which one. Put the 2 in for x. And let's see, we get 6 plus something equals 16. Has to be 10. All right, so my y value when we calculate it has to be 10. Now let's check that that works in the other equation. 4 times 2 is 8. 8 minus 10, negative 2. Works. Okay? That's all there is to elimination. You want to try and get rid of one of the variables. So their signs need to be opposites, okay, and so do their numbers, okay, in order for that to happen. That's what you're looking for.